Alright, welcome back guys. In this video here, we're gonna start with discussing derivative of a product. And then probably the next video I'll make another one for quotient functions. So up to this point, we learned how to take derivative of function, whether the function consists of a sum of two functions or a difference or a combination of those two. Here we look at how to find derivative function where the function is defined as a product and also is defined as a quotient of two functions. So I'd like to start out with this example. Let's consider this example here. Let's consider f of x to be 2x squared 3x to the fourth minus 2. Now, up to this point here, what we learned in the previous lesson is that we can find f prime of x by, simplify f of x a little bit and then apply the power rule, right? So if we distribute this here, this gives us 6x to the 6 minus 2x, no, minus 4 minus 4x squared, right? So we can simplify it that way and then say, okay, well now f prime of x is 36x to the fifth minus minus ax, right? So that's just using the power rule. Okay, but what about if we have a function that is product of two functions, but the second function is not just 3x to the fourth minus 2, but it's 3x to the 4 minus 2 to the 7th power. Certainly we don't want to sit here and expand this out 7 times and then distribute to 2x squared and get a lot of terms, and that would take forever. So we don't want to do that. So that's what the formula for, or the derivative formula for this section is for. Okay, so what I'm going to do is I'm going to introduce the formula for derivative of product, and then we're going to go back and redo this example here using that rule, and then you can see that we get the same answer here as well. Okay, so let's look at this is called product rule. Okay, and this is for taking the derivative of a function that is written in the form of a product of two functions. Okay, so this is saying that if a function f of x is defined as a product of two functions, right? Let's call that u of x and v of x, right? And we're just going to call this short as u times v for short. Okay, so if f is defined as u times v, then f prime of x, the derivative of f of x, is equal to u times v prime plus v prime times u. Oh, I think I did that wrong. So it's u times v prime plus u prime times v. Okay, so this is saying that if we have a product of u times v, then the derivative will be just the first time the derivative of the second, and then plus the first derivative times the second function. You can also write this as u prime v plus v prime u. That also works well because it's addition. You can write in any of those ways. Okay, so this is the product rule. Okay. All right. So let's apply that to our example here. So the example we just did up there, example, a function is 2x squared 3x to the fourth minus 2. So we're just going to demonstrate that the product rule does work. So we want to have the answer. We're hoping to get the same answer here, and that should be the case there. So my u is going to be 2x squared, and then my v is going to be 3x to the fourth minus 2. The derivative formula says that f prime of x should be equal to u v prime plus u prime v. Okay, well over here my u prime, which is the derivative of u, the derivative of u is going to be 4x, and then the v prime, the derivative of v, is going to be 12x to the third. and then we're gonna plug those things into this formula. So u is 2x squared, v prime is 12x to the third, u prime is 4x, v is 3x to the fourth minus 2, and let's go ahead and simplify this. All right, so that gives us 24x to the fifth, okay, and then plus 12x to the fifth minus 8x, okay, and then oh, this should be a plus right there, so that will give us 36x to the fifth minus 8x, and that is the same answer as this one here, right? So the product rule works right there. In this problem, it's kind of more work to use the product rule, but we just want to demonstrate the product rule works in this case. You know, you find this rule more useful, you know, when you have a problem like this here, where one of the function v or u can raise to the 10th power or 7th power in this case, and the product rule becomes useful. Okay, let's do another example. Let's find let's do an example with e to the x and natural log of x. Okay, using the product rule. Example: find f prime of x for the following. If f of x is 5x to the 8 times e to the x, okay, so we have, or u in this case is, we can just leave the phi as part of the x to the 8, so phi x to the 8, and then the v function is e to the x. All right, we know that the derivative is u v prime plus u prime v, and so we're just gonna plug that into what that is. So u prime is 40x to the 7, v prime is just gonna be e to the x. So u is 5x to the 8, v is e to the x, excuse me, v prime. Then u prime here is 40x to the 7, v is e to the x. We can factor out e to the x to simplify this. Actually, we can factor out 1 e to the x, and then we can even factor out phi out next to the 7. All right, so on the first term we have x left over, on the second term we have 8. All right, so that's how we simplify the answer, because now this will become useful. This part here will become useful when we solve for, you know, horizontal tangent line coming up. Okay, all right, let's do another one. Part B, f of x is x to the 7 natural log of x. My u is x to the 7, v is natural log of x. So u prime is 7x to the 6, v prime is 1 over x. So therefore f prime of x is u v prime, u prime v, and plug everything in. We get u is x to the 7, v prime is 1 over x, and then plus u prime is 7x to the 6 times v is natural log of x. When we get good at this here, we should be able to do this pretty quick, and then that can be factored x to the 6 out, so that gives us 1 plus 7 natural log of x. That's the answer. All right, one more example in this video. Okay, this example we're gonna look at how to find the equation tangent line. So given f of x as 2x minus 9 times x squared plus 6, part A, we want to find the equation of the line tangent to the graph of f of x at x equal to 3. Okay. So we're asking for whatever the graph of fx look like. Let's find the equation that tangent to this graph at x equal to 3, right? So I'm going to say, okay, suppose the graph of f of x maybe it looks like this. I don't know. I'm just guessing there. So now I just say, okay, well, when x is 3, you know, 1, 2, 3, you know, find that equation of that tangent line. Find that. Okay, that's what the question is asking. Okay, the graph may not look like that. I just make that up. Okay. So now, how do we do this? Well, equation of tangent line. Okay, that equation is y equal to mx plus b as the slope-intercept form. Okay, the y, I'm gonna extract y. The x is at 3, right? The y is gonna be the function value at 3, and then m is gonna be the tangent slope at x equal to 3, meaning m is gonna be f prime at 3. Okay, and then once we have those information, we can figure out what the y-intercept is. So that makes 3, and f of 3 is called the tangent point to the graph f of x. Okay, so let's do this. Okay, first we need f prime of x, so we need to use the product rule. That is u v prime plus u prime v. I'm gonna do this a little bit faster here. Okay, so u is gonna be 2x minus 9, so that's gonna become 2 v prime. Oh, I think I messed up already. U is 2x minus 9. V prime is gonna be 2x. U prime is gonna be 2, and then v is gonna be x squared plus 6. And then we probably want to simplify this as well, so that way we do the next step. Multiply this out. Or can we? We can factor out. Yeah, I don't know what we can really factor out here. I think this is probably, there isn't much factor beside 2. I'm gonna go ahead and simplify this. Okay, so 4x squared minus 18x plus 2x squared plus 12. So that's 6x squared minus 18x plus 12 is our derivative. This is gonna help us in part B. Anyway, so that's the slope functions. Now we can find f prime of 3. That's the tangent slope. Okay, so that means 3 squared minus 18, 3 plus 12. That should give us 12 for the tangent slope. And then now we need the y coordinate at x equal 3. So that's gonna be 2 times 3 minus 9, 3 squared plus 6. That's gonna be negative 45. Okay, so we got the tangent point, we got tangent slope. We can actually solve for the y-intercept, and then that should complete the equation of tangent line. Okay, all right, so equation of tangent line at x equal to 3. Okay, so y equal to mx plus b. Let's go ahead and plug everything in. Y is now negative 45, m is 12, x is 3, plus b, so negative 45 minus 36 is equal to b. B is negative 81. So therefore our equation is y equal to 12x minus 81. That's the tangent equation. Now the next part is asking slightly different question. Okay, it's asking for find the values of x where the tangent line is horizontal. Okay, so this is asking for the value of x, not equation. Okay, so let's say, going back to what I said earlier, let's say our graph looked like this, right? So suppose this is our graph, then if we were to draw a tangent line to the graph so that it's horizontal, those horizontal line look like this here, right? There's two horizontal line, and then we have to find what does that occur at what x value, right? So that's what we have to find in this problem here. Okay, again, the graph may not look like that. Okay, so let's do it. So we know that, okay, horizontal tangent line has slope equal to 0. So that implies that, you know, f prime of x, which is the slope, equals 0. Okay, so we have to find what x is. So now we set the derivative function equals 0. So that was 6x squared minus 18. Is it plus 18? Minus 18. X, 18x plus 12 equals 0. And we're supposed to solve for what value of x that yield the derivative equals 0. Hence, the tangent line is horizontal. I'm going to go ahead and divide by 6. So that gave us 3x in the middle, 2 right here. Let's factor that to minus 2 and minus 1. So therefore, x equal to 2, x equal to 1. So we say that horizontal line, tangent line, lines occur at x equal to 1, x equal to 2. And so that should be your answer there. Alright, so I think that should be plenty of example for this video. In the next video, part 2 of this, I'm gonna discuss how to find derivative of a function where the function defined as a quotient of two functions.